follow-up study to confirm that. CO2 is responsible for the next biggest chunk of global warming, then methane. Nitrous oxide is relatively minor, in the 1 or 2% range, I'm not really sure. And ozone is about 3 to 7% of the total global greenhouse effect. Now, here comes where the numbers get more interesting. This is how much we are increasing them in the atmosphere. You'll notice we're not really adding any, we're adding quite a bit. We're adding a whole bunch, we're adding a little bit. We're adding a little bit in our layer, not in the stratosphere. Key distinction, there's a lot of ozone in the stratosphere. We are adding it in the troposphere. And remember that industrial gases are entirely man-made.
What does it mean, 23,000 times CO2?
Okay. I hope, yeah, I think I can get that. So this is probably the numbers that are most interesting on a day-to-day basis. The College Board could ask you about any of these, so you've got a lot to know. But as a percentage of man-made global warming, the amount of extra heating that we're responsible for, because we're not adding water, that's irrelevant. Because we're adding a lot and it's powerful, we're adding a lot and it's powerful, most of our global warming comes from our CO2. But just so you know, CO2 comes from a lot of different sources. Burning of fossil fuels and burning of wood, heating, rotting vegetation, like from farms and stuff, and deforestation all release CO2.
Well, deforestation just stuff.
Yeah, deforestation prevents absorption of CO2.
Yeah, when you burn the trees. Yeah, exactly.
And that can also release the carbon.
Whatever, cutting them down.
So in this interaction, we've made 3 increases to CO2. The fuel used by the machines, the impact of burning that wood, and then the loss of carbon absorption from deforestation.
Great.
Okay. Methane is the next big thing that we are adding to, that's one of the big things in global warming by humans. And that's mostly from livestock and anaerobic decomposition. Nitrous oxide is almost exclusively from farming. Technically, there's also surgeries. That's like laughing gas. Ozone comes from electronics and atmospheric chemistry. That says atmospheric chemistry. And industrial gases come from industrial chemistry. This is an average American's contribution to global warming. And I want you to notice something. In this list, you'll notice farming shows up a lot because farming chemicals are made industrially. Farming releases a lot of chemicals that react in the atmosphere. Farming releases nitrous oxide. Farming is responsible for anaerobic decomposition and livestock contributions of methane. And farming requires deforestation, has rotting vegetation, and includes fuels. So almost all of these are influenced by your diet choices. Here's an interesting thing. When you erase one American, global warming goes down a teeny little bit, but the biggest chunk of each American's contribution is their diet. Second, their transportation. Third, their home energy use. And fourth, the stuff that they choose to purchase. The single biggest thing you can do to lower global warming is not to change your car, not to insulate your house better, not to boycott plastics or whatever, but to change your diet.
100-mile diet.
By localizing your diet, you cut down on fuel consumption, and by cutting down on meat, just skipping some percentage of your meat, just pass on the burger if you're not really in the mood.
Isn't it like, doesn't red meat have stuff a lot more like cattle and stuff like that?
Yeah, red meat is about 8-to-1 versus chicken, and about 3-to-1 versus pig.
What about fish?
What you buy.
Fish is almost neutral because we rarely farm it, so harvesting of wild foods is not necessarily a high carbon.
So fish is chilling.
You know, fish have a transportation cost and refrigeration cost,
You're still like 55 fish.
and there are other problems with fisheries. But carbon-wise, fish are pretty safe here. Now, someone asked me about this.
Oh yeah.
There are some gases, like SF6, which is a single sulfur with 6 chlorides. Those are really strong bonds. Let me give you some perspective. If carbon holds 1 unit of energy in its wobble, CO2 holds 1 unit of energy in its wobble, methane holds 10 units of energy. It's got more wobble. So methane is 10 times hotter than CO2. But SF6 is 23,000 times hotter than CO2. Because understand something really important. We build chemicals on purpose to wobble. They're called coolants. If your house is hot, we got to take away that heat with a little jar of Freon. So that Freon has to hold a lot of heat. So we build chemicals to have really strong bonds so they can wobble really hard and not fall apart. We make them on purpose for this. And when those get out to the atmosphere, you can imagine they're going to wobble a lot and heat our planet a lot when they restabilize. So interestingly, there is a whole field of chemistry which is designed to build the hottest possible greenhouse gases. It's an unfortunate consequence of modern chemistry that we need to make those things, to make computers and to make meat, plastics, pharmaceuticals, pigments, plastics, paint. To make a lot of industrial products, we have to make greenhouse gases. It's an unfortunate consequence of modern chemistry. If we contain them better, less of a problem. Okay. I believe we have talked about number 21, and I should warn you that this is a 3-star study goal. Tomorrow we will do 22, 23, 24. Okie doke. I think we might be chilling for the rest of the day. Anybody have questions, by the way? Anything about climate change today? Yeah?